All right, let's get started with covering ES6 today. Um, cool. All right, cool. So let's talk about JavaScript and really kind of how JavaScript is different now than what it was maybe 5 or 6 years ago, right? And in fact, JavaScript really. So one of the reasons why at Full Stack at least we teach JavaScript on both the front end and the back end is because it is one of the few languages in which it is able to be run on both the front end and the back end. JavaScript itself has been around for a while, but it really was until like I think like the mid or late 2000s in which something called Node came about. And the reason why Node was really powerful and really important for JavaScript was before JavaScript was primarily something that was used in the browsers, right, on the front end. So if I gave Chrome or if I gave Firefox a pile of JavaScript code, Chrome could read it, Chrome could compile it, it could make it do stuff. But if I gave this to the server, a server would have no idea how to read JavaScript, essentially, right? So basically, JavaScript was a language that was more or less confined primarily to the front end. When Node came about was essentially Node was a process that allowed you to be able to run JavaScript on the back end too. And so now what you really have is this really awesome language that could be used to power the server and also to power the front end as well. So you could build a whole web app and really build every part of a site using only JavaScript. And so that's one of the reasons why JavaScript is right now. I think based on the last Stack Overflow survey, it is like I think pretty significantly like the most common programming language out there. And it is because of the fact that it is so versatile. But that also means that JavaScript was not always like this, right? So first off, when we talk about JavaScript, what do we exactly mean, right? So there is this group of people called ECMA, and basically they're the committee who kind of decides, what is JavaScript, right? What are the things about JavaScript that make it special? And more importantly, if Chrome or Firefox or a computer is going to say, hey, I support JavaScript, what does it mean, right? What functions do you recognize? What are the reserved words? Basically, these are the people who decide at a very high level what are the rules of JavaScript. And so everything that we've been learning so far in this class has been based off of ES5 syntax. So ECMAScript 5, which is the fifth variation or the fifth standard of JavaScript that came about. All of the notation that we use, all the conventions that we use follow that. Throughout the past few weeks, Sean and I have kind of talked, a little bit about ES6 and kind of showing you, and we'll cover more ES6 today. But really, all you need to know about ES6 is that it is the next evolution of JavaScript, right? So, ES5 is JavaScript that's pretty commonly supported almost everywhere. But now, going forward, people are going to be starting to use more and more ES6 syntax as well. The other really important thing to know about ES5 is that any place that supports ES6 will also support ES5. So if you choose to continue writing in ES5 syntax, that's totally fine. Almost everywhere I can think of that would run ES6 will also run ES5, but it's more important for you to understand how to read other people's code, right? And so if someone else is writing in ES6 syntax, we want you guys to be able to at least know at a high level what they mean and kind of what some of the keywords are and how to differentiate between that and ES5. So ES5 came about in 2009, and this was probably the first major update that it had in quite a while, and it added a lot of the things in there that really now we take for granted, but really was very novel when it first came out. ES6 came about 2 or 3 years ago, and we'll talk a little bit about ES6 and what makes it a lot more special as well. ES6, if you look at other languages and how they've evolved as well, one thing you'll notice is that a lot of different languages like Ruby or Python and JavaScript, over time they all kind of converge, right? They basically all take ideas from one another and essentially try to implement some variation of that idea in their own native language. So when you look at things in ES6, some of these might, if you're familiar with other languages, some of it might look very familiar. For example, the idea of a constant, right? A constant variable. That's something that's available in C, right? And it's been around for a long time. But really, very recently, JavaScript was like, hey, we want to implement our version of constant. Before there was this thing that was, I guess, more of an informal declaration of constants. But in ES6, it really kind of came about where they were saying, you know what, hey, let's create all these things that we think will really help developers. ES6 is obviously a very kind of, it's been around for 3 years, which in terms of updates isn't that long. But there are also things that are happening in ES7 that are being developed currently as well. And so with programming, it's one of those things that you really never can just like kind of rest on what you know, because the fundamental the fundamental language itself that you're working in is almost guaranteed to always be changing, right? Python is another great example of something that happens where maybe it's not even as linear as JavaScript, right? One of the good things about JavaScript and all of these kind of different standards essentially is that JavaScript, ECMAScript comes out with 5, then it comes out with 6, then it comes out with 7, right? So you can trace it through very linearly, kind of the path or the evolution of JavaScript. If you use Python, one kind of thing that's been a source of somewhat contention in the Python community, right, is the fact that Python, the latest version of Python 2 is Python 2.7, right? Concurrently, Python 3 has also been released. But Python 2.7, but because of certain issues with Python 3, Python 2.7 is also constantly being supported. And so right now we almost have our 2 different variations of Python that are kind of not competing necessarily, but there is this argument in the community over which one to use because both are very viable and both have their own merits, right? ECMAScript is the group on the JavaScript side that helps us avoid all this by saying, look, we have ES5. This is the current most up-to-date version of JavaScript. We're going to publish ES6, and then we're going to publish ES7. And if you just go Google ES7, I think they'll start kind of listing out for you already what are some of the features that they're thinking about implementing in ES7, so you kind of make sure you're following along if that's something you want to keep track of. ES6 is currently supported. I think it's getting more and more gradual adoption. The reason why we're teaching you guys ES5 to start is because ES5 is guaranteed to almost work everywhere. ES6, there might be some holdouts still at this point in terms of supporting it fully, but you'll gradually only see more and more ES6 syntax going forward. So we just wanted you to all be prepared and be aware of it. So the other thing that to note about JavaScript and the reason why there is this lag, right, is because if you think about someone like Chrome or Mozilla, right, like ECMAScript can really easily say, look, this is JavaScript, this is what we think this function should do or what this word should do, right? But they're not the ones actually writing the fundamental language of understanding, how something gets implemented or how to interpret it in the correct way, right? Like that's Chrome or Mozilla's job. And so that lag or that time between when a standard is published to when it's fully being implemented and supported, that's the reason why we're seeing some of these time lags between ES5 and ES6. And it's the reason why there are still some holdouts on the ES6 side, because there are some groups that are still trying to figure out how do I want to support ES6 / how do I want to write my environment so that when someone writes ES6, I know what it does and I can support it and make it do what ECMA wants it to be able to what ECMA wants it to do. Sorry. The only other thing that to talk about here is very high level, the concept of a transpiler, which basically takes something that you write in one language and it kind of converts it into another language. Oops, sorry. This is somewhat useful right now for us if we're looking only at JavaScript syntax, because if we write ES6, right, in some environments, if it doesn't support ES6, allows us to transpilers. If we write ES6 in an environment that's not supported, if we write it in a transpiler, it'll be able to convert it back for us to ES5 code, so we can run it kind of more universally. But essentially, think of transpilers as kind of this temporary stopgap tool that allows you to switch between different iterations or different implementations of a computer language, right? It's something that you will almost never kind of explicitly see when you do it. Like, you could find a transpiler and write it, but oftentimes a lot of this happens behind the scenes, right? Where you could write something, in one syntax, and behind the scenes the computer is transpiling to something else, which actually gets executed, right? And if you really think about it, transpilers are everywhere because at the end of the day, what a computer really operates on are ones and zeros, right? And so to go from JavaScript to that, it does go through a lot of translations into machine code, into binary, etc. So just know that there is an infrastructure in place for us to go from either one language to another, or in this case, one iteration of a language to another iteration of the same language. Right, and so all of this is not like nothing on these slides, really should be memorized in a traditional sense, right? It's just more for you to get a concept of computer programs, or sorry, computer languages are constantly evolving. All languages are growing. There might be something new coming out every few months. And so as a developer, one of the key things you also have to be aware of is just, one is what's coming out and how do I leverage it? And two is when something new comes out, does it break something that I'm already using? Right? So JavaScript, some programmers really don't like JavaScript because there are some inconsistencies in how JavaScript is being implemented. But one of the reasons why some of those inconsistencies are not being fixed is because there's a huge code base that's already been written, that takes into account that inconsistency. So if they were to fix it, out of the blue, then that would break a lot of people's current code, right? And so keeping track of what's out there, what the current rhetoric is, and if there's any new future improvements to JavaScript, how that impacts our current code base is super important too. Any questions on this at a very high level? Cool. Yeah. So ES6 is just very similar to ES5, except we now have a few more syntax tweaks to it that could hopefully make what we write a little bit easier to read, and also makes it a little bit more powerful as well. So traditionally, up until now, whenever we've wanted to declare a new variable, we've always used a var keyword, right? And we talked about how the var keyword essentially creates this not necessarily global variable, but it creates this variable on the nearest function scope, right? So everything in this function now has access to this variable. Well, in ES5, in ES6, what they've actually introduced is two more new variable instantiators, right? One's called let and one's called const. And so what let and const does, and I think someone asked about this when we were talking about scope back in week 1, is what let does is it essentially creates it so that it just finds the nearest block scope. And by block scope, it really is just talking about curly braces. So it finds the nearest sets of curly braces, it finds the nearest block scope, and it creates a variable that can only be accessible within that block, right? So normally, if I was to say if this here was an if statement, right? If I was writing it traditionally, I'd say if this is true, create var foo equals whatever, right? That variable foo is now available to the rest of the function. If I say let foo equals something, now that variable foo is only going to be available within the confines of the if statement. And so, as you can see, what that really does is it makes us be a lot more precise about when we create variables and where we use them and who has access to them. The main reason for this is because of the fact that when we look at JavaScript, right, it is somewhat dangerous for us to always be creating variables with var that attach to the nearest function scope. And in fact, one of the best practices coming around ES6 is that really, so var is still being supported in ES6. If you use var, it still does what it normally does. You can feel free to definitely use it still. But there really should be no instance in which you ever have to use var, or you really should be using var. If you do find yourself in a scenario in which you're using var and it feels like the only way, it probably means your code can be restructured in a way that that's probably a little bit more cleaner and a little bit more safe, right? Because using vars is something that's considered a little bit less safe because you're basically giving everything in this function access to this variable, when in actuality for most variables, you really only need it in a very confined space. Okay. Sorry. So let basically creates a variable in the very traditional sense, right? It creates a variable in the nearest block scope that you can then change, you can then tweak whatever you want, like how the current var variables can be used as well. Yes.
So I have a question. Then in the example where we were looking at scope and practicing, and we were looking at all the enemies of 007, if we were to use this let, then there would be no then we wouldn't be having that discussion whatsoever. We would say, well, this is not changing this. This is confined only between those two. So, I mean, is that kind of how I'm understanding it? Or?
Yes and no. I'm happy to after the workshop go through like that exercise again, depending on what you change, because what let really does is right that like so in the 007 workshop that we're talking about, right? Basically, you had this kind of parent variable and you kept tweaking it in each of the different sub functions. Um, if we make the top variable let, that is theoretically still kind of global relative to everything that comes after it, right? Basically, let just means that you can't like this can't be read outside of this function scope, but everything in sorry that this can't be read outside this block scope, but everything inside this block scope can still have access to it, right? So we can walk through that in more detail, just so we're not crossing words here. It would change that problem a little bit, but it really would depend upon where the let is being implemented. Yeah. Cool. And then the cousin of let is const. And as the name indicates, const is usually used for variables. For constant variables. Like let, const is also block scope, so it looks to the nearest set of curly braces, and it creates these variables that can be there. That can be used within that block scope. But the thing about const is that you can't reassign something as you can't reassign a const, right? So if on line 1 I say const foo equals 1, if on line 2 if I say foo equals 2, it will throw that error that you see in the second box down there that says you can't assign something to a const, or sorry, you can't reassign a const, because consts are designed so that you assign it once and you keep it as that. The caveat to that is that if const is a data type that is mutable, so in this case either an array or an object, you can still modify that object, but you can't reassign it. If you remember that lecture that we did on pass by reference versus pass by value, right? If you're pointing to an underlying asset, you can still change or tweak that asset. You just can't ever redraw that arrow to point to anything else. That's the difference between const and let. Let, you can reassign, you can change, you can do whatever it is. You have free reign like you do with a var variable. With const, if it's a mutable data form, sorry, if it's a mutable data type, so like an object or an array, you can change the underlying thing, but you can never redraw that arrow. It has to always be pointing to that single underlying asset. Does that make sense? Okay. So in the workshop today, when you start using constant lets, right, one of the things you always want to be aware of is now where you're declaring this variable matters. Where you're declaring these variables matter a little bit more, because you're now a little bit more limited in kind of where you create them, and that determines where you are or are not able to use those variables. And actually, one of the things that I've personally kind of discovered as I started using more ES6 syntax is that another best practice is by default you almost should be using consts, and mentally by default you should be thinking, all right, this is going to be a const, and really in very rare cases are you ever going to be using a let, right? It's a good framework to do that, because I think by default, it's obviously very easy to always use var for everything because it gives you the greatest amount of flexibility, and then after that I would say let is more restrictive than var but less restrictive than const. So const is like the most restrictive, and actually that's what in a lot of cases you should be thinking about using by default. Like you really need to make a mental argument as to why you ever want to use a let as opposed to a const. Yes.
So if you have like a variable in a function, and then like in like a scope like below that or beneath that you reassign that, can you use like let to reassign a variable just for like one block scope?
Say that one more time.
Like for instance, like if you have like var message equals first var message, if you like have an like beneath that, like you have an if statement or conditional statement or whatever, and in that scope, can you like set it to just like let that variable equal like?
So basically you're redeclaring that variable within the context of that block scope.
Yeah, but I guess like a let variable or as a constant variable.
Yeah, that should be fine, because basically you're just overriding. You're basically creating this new variable that happens to have the same name, but like its value only exists within the context of that block.
Okay. And then the rules apply to anything like beneath that scope.
Right, like basically anything inside that scope, if it was ever to use like message, that variable message, it would refer to the let that was talked about. Anything outside of that scope would refer to the var that you declared outside, right? And really, like that outside one could be let as well. You could say let message equals foo, and then in the if scope say let message equals bar, right? You can use like that reference is gonna exist because like the let tells you where your outer limits are, but it goes to everything inside of that block scope, right? So the let will exist inside that if statement too.
Okay. But like for instance, constant, you would be able to do that.
Const, I think so. So let's try it out here. So basically, what you're asking is, let's just say I have two. So what you're asking is, let's say I have something like I have something up here, and I say something like const foo equals 123, right? And then you're saying if true, and then in here you're saying is let's redefine const to something else.
Yeah.
Okay, 456. So let's try it, and then we'll do console.log here. .log, and we'll say foo inside, and this will be foo, and then we'll just do the same thing out here and do foo outside. Misspell log probably, yeah. Cool. Yeah. So yeah, I guess you can redefine const. Yeah. So here, like, I guess the difference here is that you're not reassigning foo. You're creating a new variable that happens to have this. That you're recreating a new const that happens to have the same name as foo. So in this case, you can redefine let, you can redefine foo, and it's like almost like it's completely separate from the one in the parent scope. Yes.
Get rid of not inside the if statement scope, just say foo equals 456, then you would get.
Yeah, you should get an error then if you try to do this, right? Because now we're trying to redefine something that's a const, and it's a syntax error because I guess a syntax error kind of makes sense, but yeah, it's just telling you can't reassign something because it's already been assigned as a const. Any other questions on the difference between let and const? While we have this up, we can just like test a bunch of stuff. Cool. Yeah, and I mean conceptually, once you get it, it's great. Like this is the kind of thing that will like only start like you'll start feeling more familiar with it once you start using it. So at least for now, as long as you kind of mentally understand the difference between the two, that's kind of all we're asking for at this point. Once you start using it, you'll get a lot more kind of comfort around the differences between the two and kind of when to use either one. Okay, cool. So that's constant let. And I already mentioned, but var is obviously still being supported too if you choose to use that. Although if you are kind of using ES6 syntax, you really shouldn't have any vars in your functions really. All right, cool. So arrow functions. Arrow functions. So these are pretty. I guess they're both convenient and they also add an extra wrinkle to your functions, right? So before we would have something like this. Right, where we would say, hey, if we're using a dot map, what's the first argument to a dot map function?
Callback.
Right, a callback, which is a what? A function, right? And so, so here they're only showing the they're actually only showing what it looks like. So let's do it together here, right? So let's just say I have something like I'll say const ARR equals 1, 2, 3 here, okay? And I say I want to return a new array in which I add 2 to every number in that array, right? So what I'll say is I'll say const foo is equal to arr.map, and I'm mixing my syntax a little bit here, right? Because everything else I'm using const is in ES5 or sorry is in ES6. But let's just say traditionally this is the way that the callback would look, right? I would say I would pass in a function. I would take in how many arguments would I need if I want to return a new array that adds 2 to every number in the array. How many arguments does a callback take? Okay. Sorry. So it's in a map function, right? In an array.map function, its first argument is a callback function, right? So how many arguments can that callback take, and how many arguments do we need in this case?
Can't you just set however many ones you want to put into your callback function?
Well, if I do
No
some,
real limit.
well, if I do A, B, oh, I see what you're saying. If I just do like this, right? Okay, so let's say I pass in 5 different things here, right? And then what am I returning if I want to add 2 to everything? Okay, sorry, maybe let's take a step back here. Can anyone walk through me how a map function works? How an array map function works?
First one is the value, the second argument is the index.
Okay, so those are the arguments to the callback. Okay, so what is map expecting to get back from the callback?
The values inside, the elements inside the array.
Well, that's what we put into the callback, but what do we get out of the callback?
Creates a new array with the results of calling a provided function on every element in this array.
Okay, so what are we expecting to get from the callback in this case?
An array?
Not exactly. Right? We're looking to get back an array from the dot map.
Okay.
But what are we looking to get back from a callback?
Value from that index that you're on.
That's what gets fed into the callback, right? So what do we get out of the callback?
An altered value of the index.
Right. Basically the value that we want in the output array, right? So how this is going to work is basically this callback, we're going to give it what's already in our array, and the callback is going to give us the value that we want to put into the new array, right? Because that map gives us back a new array, right? So how do we know what values go into the new array? We look to the callback, right? We give the callback and say, hey, callback, here's what we currently have, and the callback to say, great, here's what goes into this slot in the new array, right? So the callback is going to give us back a new value that we're going to essentially push into this new array. So in this case, if I want to have this function increment every number in my original array by 2, what would I write on line 4 here? I hear whispering.
A plus 2.
A plus 2? Like that?
Maybe return.
Okay, let's test it out. So we do console.log, and then we'll say this is foo here, and then let's see what we get. Great, I get back 3, 4, 5, which is exactly what I wanted, right? This return is super critical because if this doesn't return anything, then what is this callback going to return to us?
Undefined.
Exactly, we're going to get a row of 3 undefineds. Or sorry, an array of 3 undefineds. Cool. So this return is super critical, okay? So this is basically what happens in ES5, right? And so yes, to your point, here we can pass in as many arguments as we want to. Actually, here's a good practice for this. And actually, there may be some surprise.
I don't get this entire,
I'm sorry?
not understanding the entire example. Sorry.
Okay, cool. Yeah,
Not
we'll
following.
we'll spend some time on this because arrow functions are pretty valuable here. So let's B, C, D, and E. Okay, cool. And essentially, all I'm doing now is I'm trying to figure out like which elements are being passed into this function, right? So, oh god. Okay, so let's just take a look at these two. Okay, we're using a dot map, right? And we're basically feeding 5 variables into the callback. The first element here is A, and what is A going to be?
Since it's 1.
Which is also what?
The first value. or
Right.
value
The
of
current
first-
index of the map.
Well, the current index wouldn't start at 1, right? It would start at 0.
Well, I mean, it's the current element.
Right, it's a value, right? So A is a value, so we can call this, so we can just maybe make a, oops, God, okay. We can make a comment here that says A, this is just a current value. Okay, so then what's B?
0, I guess that's
The
the
index.
index.
Right, B is a current index. And what's C?
The entire array. That's the value of A or R.
And then what's D and E here? Right. And so this is what I was asking earlier is how many arguments could a callback function in a map take? and how many do we need. Okay, so you're right that we could pass in as many variables as we want. We can make this a list of like 100 arguments, but by default, map only has 3 to give to the callback, right? And it's always going to give it the current element's value, the current element's index, and the entire array. Everything else is going to be undefined because essentially we can declare this variable, but there's no value behind it because map is not giving anything to the callback. Okay, and so really, when we think about kind of what a callback a map takes is it takes in up to 3 arguments, right? The first argument is always going to be the value. The second argument is always going to be the index, and the third argument is always going to be the array. Now, in this case, I'm only looking to get the value back. So what I could actually do is I could only just say, hey, just give me the first argument, because that's really all I need at this point, right? Like I don't need the index, I don't need the entire array. I'm just looking to increment the value by 2, so I just need the current value. However, if I had wanted to do something with the index, then I would need to do something like this, where I need to say, okay, give me the first 2 things. Even if I don't use value at all, I need you to give me the value before you can give me the index next. And so that's why in that case, I would take in 2 arguments. And if I wanted to do something with the entire array, then I would say, regardless of how many arguments I need, because I need that third argument, I need you to pass me all 3. Okay? So this is just a quick recap on how array functions work and how callbacks work, right? Is in this case for a map function, a map is going to pass certain things to its callback. Like we don't ever see it here, but that's what's happening behind the scenes is for a map function, the map is always going to give the callback the value of the element, the index of the value of the element, the index of the element, and the entire array. Okay? Is everyone good with kind of what this is doing now? Like what we're seeing here, how this callback works, etc.
So what's the return supposed to be? A plus 2?
Right. So basically what this callback is going to say, okay, is that for every single element, right, what do I return? So you can add that to the new array you're returning. So this callback is going to run how many times here?
It should run 3 times and you should get 3, 4, and 5 as the result in one array.
Yep.
Can I see what?
Well, that's I forgot to define a C here, but yeah. Actually, I'll just remove these because these are making it messy. But yeah. Right. This callback is gonna run 3 times because the definition of this means that we run this callback on every single element in this array in sequential order. Right? So when we run it on the first value, essentially what's happening inside of here is we're creating an empty array to start and saying, all right, what do you want me to put in for this first value here? And the callback will say 3. So because it's returning 3 here, so we put a 3 into that array. When it runs in a 2, it will ask us, okay, great, what do you want us to put in the second element in this array? And then we'll feed that 2 into the callback, and the callback will say 4. So we put 4 in the result in the new array. And then finally we'll do the same thing for 3, and the callback will return 5. And so we add the 5 to the new array. And so that's why when we put on this new array, it's 3, 4, 5. It's because that's what the output is when we feed something new into the callback each time for every element.
So it returns as an array because array.map is formulated to gather all those elements and push them all into an array.
Yeah.
That you will make equal to constant.
Right. Array.map. So if you look at your notes, like .map is going to return a new array, right? And that's a lot of times people do something like this, for example, where they try to do something like this, right? And the assumption is that okay, well, here if I do this, I'll just change ARR and print out the new value. And when they do that, they'll see that ARR doesn't change, right? ARR stays the exact same. And the reason why is .map always returns a new array. That's why .map, is what it is, and that's one of its kind of special properties, that because it does return a new array every time, essentially .map uses the callbacks to figure out what numbers go into that new array. Okay. None of this is ES6 yet. I'm sorry for dragging this up, but just so everyone's clear on callback, because this is actually super critical for understanding kind of how. Because the problem is and you actually see, let's just jump to a ES6 example here, right? So what ES6 does is basically says, okay, let's take a look at all this text I need to do to write a function, right? And how much of this is like unnecessary, or how much of this can I maybe abstract away, right? And where ES6 initially starts, it says, okay, you know what? I don't need to write the word function. By having a parentheses like this, like this thing here, by having a parentheses with certain common delineated parameters, this basically implicitly states that I'm going to be creating a function with these arguments. So when it sees this, it basically just assumes that this is kind of the argument that goes into a new function that you're creating. That's one. Okay. The second thing it does is it's called an arrow function because it uses an arrow, right? And so what an ES6 compiler does is it will see this syntax, it will say, oh, here's an arrow, and I see a variable in a parentheses before it. This just means I'm declaring a new variable now that does this, okay? And here's where we can be as complicated or as maybe as clean as we want here, right? So this will run perfectly fine. This is quote-unquote valid ES6 syntax for declaring a function, right? We're saying we're creating a function. That's what this arrow tells us. Here are the arguments that go into the function, and then here's the body of the function. But the other thing that ES6 lets us also do, kind of in a very straightforward way, is that if we're returning something very short, i.e., if we're returning an expression, what we can actually say is we can actually get rid of the return and even get rid of the curly braces. And what this tells us, or what ES6 interprets this as, is, hey, let's create a function that takes in A, B, C as arguments, and the output is gonna be an expression that I'm just going to implicitly return. So in this case, what this is happening here, and this is gonna run perfectly fine, is basically this is gonna say, hey, return A plus 2. You don't see the word return, you don't see the word function, but this is essentially creating a new anonymous function that takes in everything to the left of the arrow function and returns everything to the right of it. Okay? The reason why this is a bit more tricky to use is this basically takes in an expression, which means it's only taking more or less one line of code, right? I can't write multiple lines of code there. I can't be like, var foo, like, or like, like let bar equal A plus 2 return bar plus 3, right? Like, if even it basically it's gonna throw an error at me, is because this is not an expression, right? This is the multi-line bit of code. So if I want to get around this, then I still need to bring back my curly braces, and if I do use my curly braces, then everything runs fine. Okay, so ES6 makes writing quick anonymous functions that return expressions a lot faster. Right, this is just like a lot less typing for you to kind of get something out of it. The other thing that this does that's also not as clear, maybe not as apparent, is normally whenever you create a new function, within that function you also create a new reference to something called this, right? And this is basically the reference to the parent. Okay, if we were to use ES5 or ES5 syntax, every time we create a new function, we're creating a new version of this that's referring only to this function scope. What ES6 does, or this arrow function does, is it actually lets you keep the this that refers to your parent. Okay. This, like the idea of this is something that's like a pretty complicated idea that like you actually cover more in depth probably in your bootcamp experience. But the reason why I'm just bringing it up here is to let you know that this is not purely like ES6, like this arrow function here. It does make typing, it does help you type less. It makes things look cleaner and shorter. But there are also underlying value to it, like maintaining a reference to this that helps you when you write basically more complicated functions, essentially. Okay. So is everyone comfortable with kind of what we're looking at here, what this expression or what this arrow function is doing? You use a curly brace when you want to write basically something that's not an expression, right? Something that can't be evaluated in one line. So anything that's more than one line, you're guaranteed to need to use a curly brace. And in some cases, you might also want to use a curly brace even if it is one line, if you don't want to return it. Right? So like let's just say I want to do something like I now have something, let's say, I have foo bar here, and I have this is go to an empty array, right? Here, even though it's not best practice, I could do something like foo bar dot push a, and if I run this, this is gonna give me. Let me try. Oh, right, because I'm maintaining context to this. Okay, so basically this is going to return whatever the output of that value is. But if I add curly braces around it, now you'll see I'm actually creating this new foobar variable that duplicates it as opposed to just returning it. So without having these curly braces around, what it does is it actually just goes through, it pushes it, but then it also returns whatever is being pushed out, whatever is being returned from this push function into the new array. But if I don't want to modify it, or if I don't want that to show up in the new array, if I only wanted to do what it does in here without returning the value, then I add the curly braces, and now it's going to return undefined every time, but it still does what I initially wanted to do, which is populate this new foobar variable. Okay. So basically, if you ever want to return anything that's like short or a single expression, you can leave off the curly braces. But anytime you want to do anything that requires more than one line of logic, you want to put back the curly braces to basically create that function scope. Okay, cool. Does anyone have any questions on this arrow function now still? What it does, how we use it.
So we're using this for an anonymous function, but we can't use it for an int function.
I do not believe so. We can try it though. Yeah, looks like not. Cool. So let's go back to the arrow function here. Okay, cool. So yeah, so arrow functions, we can now basically create anonymous functions a lot faster with the arrow function. It helps us maintain the reference to this, which is basically like which scope are we referring to essentially. And a lot of people just use it because you type less and it looks cleaner when you type it out. But because of the fact that it returns a single line expression, just be careful of that, and just know that like it's not purely just a visually aesthetically pleasing thing. There is kind of use cases behind it too. Okay, and then the last thing is basically ES6 also added some new string methods, right? So essentially, if I wanted to check, like if this particular substring exists in the original string, I now have something called .includes. If I want to print out a string X number of times, I can do repeat. And then if I want to check to see if a string ends with or starts with a certain string, I also have that as well. So basically, these are just kind of like nice to have, like fun little sub functions to your classes, and there will be more added as well. But essentially, these are things that the developer said, okay, here are some common use cases that people have. People do with this language, and they're implementing it kind of by hand. Let's just introduce prototype functions that can do this a lot faster out of box without you having to rewrite a lot of this. Okay. And there's a bit more things too. And if you ever want to learn more ES6 syntax, literally just Google ES6. And I think the first thing that comes up is going to be the Mozilla Foundation or from the ECMA Foundation. That's going to tell you exactly kind of what's been changed and what the new implementation details are. But so far we've covered between the const and the lets and the arrow functions are probably like the 2 or 3 like main things you'll need to know about ES6. Any questions on ES6? Yes.
For the constant, I'm not clear on why it's different from let. You are unable to change it at all?
You are unable to reassign it.
Okay, so if I have a constant array with 1, 2, 3,
Mhm.
I can't say on the next line var or let new variable equals ARR. Is that what you're saying?
Not exactly. So if I have something here, right? If I say const array equals 1, 2, 3, and I say, oh, AR now equals 4, 5, 6,
Oh, okay.
I can't do that. I basically can't ever write AR equals again anywhere else in my document, right? If this is a let, totally cool.
Okay. But then can I add an element to
Yep.
the constant array?
Yep.
Like
If this
an
const is
array?
something, yep. If this const is something that can be changed, like an array or an object, you're definitely feel free to array.push something to that. But if this
Changes it, but you can't replace the entire.
right, so remember like how like you have a variable name, right, and it has an arrow to an underlying asset. If you can, feel free to change that underlying asset, but you just can't redraw the arrow to point to anything else for the rest of this document. Right? It basically means you can't reassign this to anything else. Right? On the other hand, if this is const array equals 2, and I do, oh, let's increment 2, what's going to happen here?
Equal to 3.
Oh, I shouldn't call it AR anymore, but yeah. It's going to throw an error, right? Because 2 is not a mutable data type, right? It's not an array object. You can't change 2. 2 is just a number, right? So basically, by doing this, what you're really saying is, for the rest of this document, ARR is always going to be equal to. You can't ever change it. You can't ever reassign it. So if I ever see this variable again, I know exactly what it is. And so usually when you look at a function, right, like we talked about before, how the usual layout of a traditional kind of script is like, like you have your variables at the top, then your functions, and then kind of your execution of these different things. Now when we have let and const, you almost always see the const at the top of the variable pile, right? Because usually when you see a const, it really just means like, hey, these are the variables that we're going to have in here, and for a lot of these, you're not even going to be able to change them even if you want to. So just know what they are up front. So it's another coding best practice.
And it's only because if you use the constant keyword to declare a variable, and it's a string or a number, you cannot actually change it. But
Yep.
if it's a object or an array, you still can.
Right.
You can modify it, but you can't sort of replace the whole.
Yep. Exactly. And just keep in mind that really it's just objects, right? Because arrays are just objects in JavaScript. They just have a little bit few extra features in there, but underneath the hood, they're just objects. Right. Yep. So something like like if I want to do something like this is gonna barf and tell me stop what you're trying to do. Cool. Are there any other questions on arrow functions or lets versus const? Okay, great. So we have a lot of time today, right, for the workshops, and hopefully you guys get through them. But if you do finish early, I also really encourage you to go back and visit the higher order functions workshop that we did, I think, mid last week, maybe last Wednesday. This is one where we did use things like .map or .reduce or .filter, and try rewriting a lot of those with ES6 syntax to really understand kind of how ES5 looks, how ES6 looks, and to understand kind of like the way to translate between the two. The problems tonight will allow you to use ES6 syntax, but in my experience, redoing the previous lecture on higher order functions also just gives you a good extra dose of practice on that front as well. Sound good? Any last questions on ES6 stuff before we move on to the workshop? Between let and what? Let and var. Let basically creates a variable that's confined to the nearest block scope. Okay, var confines it to the nearest function scope. Right. So if I create a var in an if statement inside a function, everyone else in the function can use it. If I use a let, only people in that if block can use it. All right, cool. I will stack out your groups now. And feel free to take a break, and then you guys come back. Feel free to get started. It's only 7:35 right now, so I guess we'll see where you guys are. But if everyone finishes this workshop, we can maybe start the review around like 8:45, maybe 9ish. And then if people finish early before that, we can even go back and revisit some of the higher order functions practice problems as well. Cool.